All right, part D. Find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. So this is an odd, tricky sort of problem. It's not hard to do, but it's different than what you're used to doing. Most often, I would see differential equation problems on the AP test where you separate variables, find antiderivatives, solve for constants of integration, solve for y or solve for a variable, and maybe also have to include some restriction on the domain. But this one's very different. So here's how we're going to go about this. I have this, and I know that this has to be a solution. So I can go ahead and say, okay, if this has to be a solution, I also know that dy dx has to equal m, because it's linear with slope m. So dy dx equals m. We know dy dx from the differential equation equals 2x minus y. And I can set up a little equation between these two. M equals 2x minus y. Now, if y is mx plus b, I can substitute this in here and get rid of an extra variable here. I want to figure out what m and b are, but this is sort of hanging around. So I'll do that. M equals 2x minus mx plus b. So m is 2x minus mx minus b. And since m is sort of a literal constant, it's not changing, I need to get rid of all of the x here. M cannot be defined in terms of x. X is a variable. So this lets me know that for the variable part, 2x minus mx has to equal 0. And then for the literal, the constant part, I know what's left over, this m and this negative b. M will equal negative b. Solving this for m, we can factor out x, get 2 minus m equals 0, and this tells me that m must equal 2. And over here, if m is 2, and m is equal to negative b, that means that b has to equal negative 2. So it's more of an algebra problem with one calculus step, this one step right here saying, okay, I found a derivative, and the rest is working with multiple equations and solving some stuff.